All right, so this is going to be a video about area between curves, and to kind of show you the idea behind this, the concept behind this, I have this example here where we're trying to find this area between 1 and 2, so x is 1, x is 2, and we're trying to figure out what the area between these two curves is right here in that spot. So it's basically bounded by x equals 1, x equals 2, and then this bottom part of the graph and this top part of the graph to try to figure out that area right there. Now, the way I want you to think about this is imagine if you just found the area of this top function all the way down. Well, that's what we have right here. You notice it's the top function all the way down. Now, that third image here now is just this bottom function all the way down. That's what this represents right here. All the way down to the x-axis is what I mean. And if you notice, to find the area between, all you have to do is subtract the area from that top one to the x-axis and subtract the bottom function to the x-axis to figure out that area in between. And it's basically always going to be like this: the area of the top function to the x-axis minus the area of the bottom function to the x-axis. And that's kind of what I have right here in this image down here. I'll zoom in here so you can kind of see it. The region between two curves, all you have to do is do the integral from a to b. Okay, so in the example above, it was from 1 to 2. This one is from a to b, so you can see in the formula a to b. It's the function on the top, which is labeled as f, so this f1's on top, minus the g1, which is on the bottom, because it gets rid of this negative space right here. So that's essentially all you're going to be doing when you see these problems. Is it definitely helps to have a graph or an idea of what the graph looks like, and you're going to be doing the integral of the top function minus the integral of the bottom function, and that's what we're going to basically be showing for the rest of this video. Is I'm going to show you a couple of example problems. It's a pretty straightforward concept, but you have to understand that formula first to really understand it. So let's actually do that example problem that we started with, where it was those two curves and I was trying to find the area. The functions I have listed over here, where it says find the area of the bounded region, f of x right here, and then g of x right there. In this case, the f function is the top one and the g function is the bottom one. It's not always like that, but for this particular case, it's going to be. So we're going to use that formula on the bottom to kind of set this up. First thing I'm going to do is write the integral. Now, it does say it's bounded from x equals 1 to x equals 2 right there, so I'm just going to be using that to figure out my a and my b values. It's also shown in the graph, so you can kind of see it yourself. It is important to note that sometimes those values are not given. I'm going to actually show you the next example problem where it shows that. You will not see the a and the b value. You actually have to figure out what those a and b values are. It'll make more sense when we look at that other problem. Let's keep doing this one. So we're going from 1 to 2, and it's going to be f of x, because it's the one on the top, minus g of x. Now, it is important to note that you have to make sure that f is on top and g is on the bottom. Don't just follow the formula. The formula is based on that example graph that's given, so don't just assume f is always on the top and g is always on the bottom. You do have to actually make sure of that. So we have something like this, and if you remember, to figure out the definite integral, we have to do the antiderivative of f, the antiderivative of g, and then we're going to be plugging in 2, plugging in 1, basically, and then subtracting those values. So that's what we're going to do next. First thing I'm going to do is find that antiderivative of f, which is listed right up there. So I'm going to use reverse power rule on this, and it's going to be negative 1/3 x cubed, so we're going to add 1 to the power, plus 2x squared plus 3x. So this right here, all that is our f antiderivative. Okay. And then I'm going to put this in parentheses just to kind of group it. You don't obviously need that, but I'm just going to do it for fun. Okay, then we're going to subtract off what our g is. But we have to do the antiderivative of that g. Okay, in this case, I'm going to switch colors, and I'm going to have to use parentheses this time. It's going to be 1/4. So the antiderivative of that negative x to the third is negative 1/4 x to the fourth, plus 7/3 x cubed. It is important to note, if you forgot how to do antiderivatives using reverse power rule, you are going to want to review that from your previous calculus class. You should know how to do that by now. That is kind of the prereq to doing these. You have to understand how to do the antiderivatives. All right, 7/3 x cubed minus 5x squared plus 5x. So we're integrating this from 1 to 2. Zoom out a little bit here. starting bracket right there. All right, now from here, before I plug in the 2 and plug in the 1, what I'm going to do is simplify this as much as I possibly can. First thing I'm going to do is flip the sign here, 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 and here by distributing that negative. And then I'm just going to put it in ascending order based on the power. So I'm going to have 1/4 x to the 4th. Okay, so that's this one right here. I'm going to try to color code this to keep it organized. All right, this part right here, the negative 1/3 x cubed and the negative 7/3 x cubed, that will combine to minus 8/3 x cubed. All right, we have the 2x squared and the 5x squared, which is going to be 7x squared. And then we have the 3x and the negative 5x to be negative 2x, and we're integrating that still from 1 to 2. All right, from here we're going to plug the 2 in for the x and the 1 for the x, and then subtract those values. So if I plug the 2 in, you're going to get 16 divided by 4, which is going to be 4. Put this in parentheses just to kind of keep it organized. Minus 8/3 times 2 cubed is 64/3. Plus 7 times 4 is 28. Minus 2 times 2 is 4. And that's when you plug in the 2. Now if you plug in the 1, it's going to be a lot easier because all those x's are just 1. So it's 1/4 minus 8/3 plus 7 minus 2. Okay, now we got to do a little bit of work to simplify all this. All right, this right here is going to be 24. Plus that 4 there is going to be 28 minus 64/3. Minus, all right, I'm just going to flip these to make my life a little bit easier. Okay, and then it's going to be, that's going to be negative 5, so we'll just do negative 1/4 plus 8/3, and then there's that negative 5 right there. Onward we go. 28 minus 5 is going to be that 23. Negative 64/3 plus the 8/3, that's going to be negative 56/3 minus 1/4. All right, we're going to do common denominators here. Let's just make it 12 to make our lives a little bit easier. So I'm going to multiply the top and the bottom, that 56 by 4 and that 3 by 4 as well. And you should get 224/12 minus 3/12. All right, so now it's going to be 23 minus 221/12. The 23, if you multiply that by 12, you're going to get 276/12 minus 221/12. And again, you can simplify this however you want. This is just how I'm doing it. And the final answer should be 49/12. If you notice, all I did was follow the formula. Step by step, simplify as needed. You don't have to simplify the fractions the way I did it. If you have your own way of doing it, that's completely fine. It's completely up to you how you want to do it. Now this next problem, you're going to have two functions, but if you notice, they don't actually give you a boundary for it based on the x. It just says find the area of the bounded region. All right, to figure out what this bounded region looks like, I'm just going to sketch a real rough graph of what this is going to look like, but it's based on the intersection. So before it said to integrate from 1 to 2, this one, it says the bounded region. So we need to figure out what those x values are. And the easiest way to do that is to set the y equals x and the y equals x squared minus 3x plus 3 equal to each other and solve. So that's the first thing we're going to do. So I'm going to set the x squared minus 3x plus 3 equal to x. Now, wherever these intersect is wherever these are equal. So once we figure that out, we'll be able to sketch the graph and kind of see what we're working with here. All right, now it's quadratic. So if you remember from your previous math classes, we have to get the quadratic set equal to 0. From there, we're going to factor this and solve. This should all be a review for you. And then from here, we have x equals 1 and x equals 3. So right now, we have at least an idea of what this graph is going to look like. I'm actually going to draw it out right now. So we're going from 1 to 3. Okay, if you plug in 1, you're going to get 1 for the y. So it makes it really easy to sketch this graph. Same with the 3 because y equals x. So if the x is 3, the y has to be 3 as well. So we have something like this where they intersect. Now y equals x is just a line, so I'm just going to connect the dots with a line. The other one is quadratic, and it's quadratic facing up because it's positive there. So what we can do is just kind of do that. Now, is that exactly what the graph looks like? Absolutely not, but at least it paints an idea in our head of how to solve this problem. Now we know what the top function is. Now we know what this bounded region looks like right there. So now we can actually figure out what this area is. So let's do that. Let's set up our formula. So the area is going to be equal to the integral from 1 to 3 of f of x, in this case it's x, because that's the one on the top, minus the function that's on the bottom, which is x squared minus 3x plus 3 dx. Okay, I'm going to zoom in here. Okay, from here I'm going to actually simplify first, so I'm going to distribute this negative here. X plus that 3x here becomes 4x. I'm just going to cancel that out and put 4x right here. So now we have negative x squared plus 4x minus 3 here. So from there I'm going to do the antiderivative. I'll do the antiderivative of that negative x squared first. So that's just going to be negative 1/3 x cubed plus 2x squared, the antiderivative of 4x, minus 3x, which is the antiderivative of that minus 3 at the end there. Okay, and we're integrating from 1 to 3. So we have to plug the 3 in, plug the 1 in, and then subtract those values. So when you plug the 3 in, you're going to get negative 1/3 times 27, which is just going to be negative 9, plus 2 times 3 squared, which is 18, minus 3 times 3, which is 9. So that whole thing is a wash there when you plug in the 3, which is fine. Makes our life a little bit easier. Negative 9, and 18 is all 0. Minus, okay, now when you plug in 1, you're going to have negative 1/3 plus 2 minus 3. So it's going to be 0 minus all of that. I'm going to distribute the negative again just to make my life a little bit easier. Okay, so it looks like you're going to have 1 plus 1/3, which ends up being 4/3, and that is the answer for this problem. All right. So you're basically going to have two different flavors of this types of problems. You're going to have one where the x values are given, so whatever you're integrating from, in this case the first one where it was 1 to 2, sometimes it's given, sometimes it's not, and you have to actually figure out what's going on. So it's basically one extra step where you have to figure out the intersection for that. So that's a quick video of area between curves with two example problems. If you have any questions about anything in this video, let me know.